I'm Anil Kumar. Welcome to my series on algebra. Here we have a very interesting communication and thinking question. The question here is, consider a checkboard with 64 squares. A penny is placed on the first square. Double the amount is placed on the second square. This process is repeated for the entire board. How much money will be on the entire board? You can always pause the video, answer this question, and then look into my suggestions. Let us see how students in different grades will be in a position to solve this, right? So let's talk about students who are in grade 8 and in grade 9, right? So let's say the question is for them. They haven't really learned about geometric series, right? But they know how to work with exponents. So they know how to work with exponents. So let us see how they will solve this particular question, right? So let's go through it once again. We have 8 by 8 board here, which has 64 squares. A penny is placed in the first square. So we have amount equal to 1 here. Double 2, double 4, 8, 16, and so on. The money is placed on the board, right? So that is how you are going to fill this up. What do you notice here? Well, if you look into this pattern, 1, 2, 4, 8, 16, you will see that 1 basically is equal to 2 to the power of 0, right? That is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So the pattern actually moves on like this. So on the first square of the checkboard, you are placing 2 to the power of 0. On the second, 1 less, right? So in general, if we have the nth one here, then you'll place 2 to the power of n minus 1. So 1 less, right? So on the first, second, third, fourth, fifth, right? On the fifth one, 1 less. So that means if you continue this pattern, then on the 64th, you will place how many pennies? 2 to the power of 1 less than 64, which is 63, correct? So I hope this is the first part, which is absolutely clear to you. So we'll have here in the form like 1, 2, 3, 4, 5, 6. So here we'll have 2 to the power of 5, then we have 2 to the power of 6, 2 to the power of 7, and then at the end we'll have 2 to the power of 63, right? So this will be 2 to the power of 62, right? So likewise, we can fill up all the pennies. So many pennies will be there on each box, right? Now, let us get a method to find how much money, that means when you add them up, all amounts, if we add them up, what do we get? This is what we need to figure out. How can you do this? Well, the strategy is kind of like this. We'll call this sum of money, right? So let's say S be the sum of money. So in our case, S will be equal to, we can say 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus so on till 2 to the power of 60 plus 2 to the power of 61 plus 2 to the power of 62 plus 2 to the power of 63. So that is our last term. Clear? Now, we need to calculate this S. The best way to do it is like this. We can multiply this by 2. So if I multiply by 2, I get 2 times S equals 2. Now, if I multiply by 2, what do I get here? Well, I get here 2 to the power of 1 plus 2 to the power of 2, right? So these numbers, when multiplied by 2, will change like this. Is that clear? So this one power is increased. Do you see that? So So that is how we'll see that these numbers have changed, right? So I'll not write so many, we'll just write the last two. So it'll be like 2 to the power of 63 plus 2 to the power of 64 to end with, right? So we get S, which we want to find is this series, and twice that S will be, when you multiply each term by 2, you get that series. Now see what happens if I take away, let's say we call this as our equation 1, this as equation 2. What happens when I do 2 minus 1? Well, if I do 2 minus 1, I get S equals 2. Now here, I'm taking away the first equation from the second. So this and this will cancel, this and this will cancel, these will cancel, correct? So likewise, this will cancel with this value. And you'll find all of these terms, 63 will cancel with 63. At the end, we'll be left with 2 to the power of 64, right? So basically, we are left with 2 to the power of 64 minus 1. So S is equal to 2 to the power of 64 minus 1. Do you see that? So we get our answer. This is the total amount in exponential form. So how much money will be left? The answer is money, everything in green, will be 2 to the power of 64 minus 1. That's a huge amount of money, right? So that much of money will be left. Now this is, we'll call this as our method 1, which actually can be adopted by any student doing algebra. Even a grade 8 or 9 student can solve it using this method. So this is basically a challenge question for our grade 8 and 9 students. Now the method 2 will be using the series, right? So in method 2 we use geometric series. So for them it is relatively a simple problem. We know the formula for a geometric series is the sum of numbers is equal to a times r to the power of n minus 1 divided by r minus 1, right? So in our case, a is the first term, right? So in our case, the first term a is equal to 1. R is the common ratio. R is the ratio. So you're multiplying everything by 2, right? So times 2. So that is the value of r. So r is 2 for us, and n is the number of terms which we have, which is 64. So when I place these values in the formula, then we get sum of 64 boxes, the amount placed here will be 1 time r is 2, 2 to the power of n is 64 minus 1 divided by 2 minus 1. Now 2 minus 1 is 1, so we are left with 2 to the power of 64 minus 1. So it's a straightforward solution for the students in high school who have already learned geometric series, right? So for them it's a very simple problem. So I hope you understand all these steps here and see how we could apply our learnings and solve such questions, especially at a very young age when we just begin the high school. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.